Okay, good morning, everyone. Good afternoon, everyone. How did your homework go? Do you have any questions about the homework? Please get going. Can we do number 17? Number 17. Okay, we won't do all of it. We will do a piece of it. So let's look at number 17. Okay, this one I definitely need the picture here. Okay, so here we actually have to read the graph. So the whole idea here is to read the graph. So what's G composed with f of 4? So let's see, according to us, f is the upper one and G is the lower one. Okay. So what's G of f of 4? So it's basically G of f of 4. Okay, that's how we should write it. If you write it like this, you're fine. You have to start writing it this way. And now I ask myself, okay, what is G of 4? G is this curve right here. This is an input of 4. What does G of 4 is? Sorry, it's a G of f of 4. So I need f. Apology. This is 4. What is f of 4 is? So according to my picture, this is f of 4. So f of 4, this is equal to 0. And then I have to compute G of 0. So I go back, okay, what does value G takes at 0? This is 0. What does it take? That's a closed circle. This is equal to minus 4. Okay, so let's do 3 along the same lines, but this time you guys will have to help me. What's G composed with f of 2? So step number 1, this is G of f of 2. Okay, so what's G of f of 2? So what is f of 2? Minus 2, so this is 2. F of 2 is minus 2, so this is G of minus 2. Okay, and now what's G of minus 2? Now I go back to my graph. Minus 2, so this is 0, that's a minus 2, and I need the G value for it. According to my picture, it seems to be negative 6. All right. Okay, I'll pick one. For example, f composed with f of minus 5, and then we proceed. So what's f composed with f of minus 5? The first step is you have to write the definition of it. It's f of minus 5. So you start with minus 5, you evaluate f of minus 5, that's now your input, and then you evaluate f at whatever you're getting here. So it is going to be equal to f of. All right, what is f of minus 5? Again, I need to go back to my picture. So 1, 2, 3, 4, 5, that's 5. F of minus 5 is equal to 3. So I need f of 3. I found my input. Now what is f of 3? Again, that's a 3. Okay, I need f of 3. If this is 3, f is the upper curve, it's right there. So this is equal to minus 1. All right. And the rest is verbatim the same. So I will not do the rest because it's actually more than a repetition. All right. Any other questions from the homework? All right. So today we're going to start section 2.6, I guess. Let me check the number. Yeah, so we're looking at section 2.6, which is the inverse function. So I can erase that now. Inverse function. Inverse function. So, okay. So what we're going to do is we're going to create a new function that we're going to call the inverse of f. That's what we're going to do today. And we're going to, and we're not going over to, if I have time at the end of the semester, I will go through 2.5. All right. Now I'm going to move to 2.6, but I promise to go through that hopefully by the end of the semester. Now I want to make sure I finish what is essential for you guys. All right. So inverse function. So we're going to construct a new function, as I said, and we're going to call the inverse of f. So let's see what this is about. Suppose you have a function f, and the input are two numbers. Let's not make a big deal. This is the input, are a and b. And my function f is going to take, let us say, a to 1, for example, and it takes b to 2. So that's my function f. Okay. So here, a, b are the input. So the domain, if you want, consists of a and b. So that's the input. So those are the input values. And those are my output values. All right. What is f inverse? F inverse is a new function which does the following. It's going to take for input the output of f, and it's going to assign to them the input of f. So let us draw the picture. What is f inverse? F inverse, that we are going to have a notation for it like this. A bad notation, but that's the notation. What it does, it's going to move backward. So it's going to take, I'm going to draw it like this. These are the input of f inverse. And it's going to take 1 back to a. So that's the new function. It's going to take 2 back to b. So it's going to reverse the process. It's going to go this way. So that's what's the f inverse of a function. It means it takes the input of f inverse are basically the output of f. And what f inverse does, it takes the output of f back to that input. So in this way of writing, the domain, so it's a new function. That's a new function. That's the rule. So the domain of my new function is actually the range of the other one. So this is 1 and 2. Because if I go back to this function, the range of f are all the output value. So for me, the range of f is 1, 2. When I'm going to construct a function that starts from here and go backward, the domain is going to be the 1, 2, and the range is going to be basically the a and b. So we're actually moving backward. All right, so that's the idea of, so that's a new function. So let me give example number 2. And then we give it like a rough definition. So example number 2, suppose I have the following function f. So this is x, and this is f of x. And, just a simple table. So for example, I'm going to send 1 to 2. I'm going to send 2 to 4. And I'm going to send 4 to 6. Okay, nothing special. So in this picture here, in this picture, f of 1 is 2. F of 2 is 4. F of 4 is 6. Now we're going to build f inverse. So what is f inverse in this picture? So I'm going to build here the inverse. Okay, f inverse is going to take for input the output of f. So it's going to take for input 2, 4, 6. What's going to assign to them? It's going to take 2 to 1. It's moving totally backward. It's going to take 4 to 2. It's going to take 6 to 4. Okay. And what's the notation for f inverse? So suppose I call the input, I use the letter t. This would be, that's the notation, f inverse. So that's really the notation of t. So f inverse is the function that takes the output of f back to that input. So here, I'm going to write the value of f inverse. So f inverse of 2 is 1. F inverse of 4 is 2. And finally, f inverse of 6 is equal to 4. So it's a function that's really moving backwards. So that's the idea of f inverse. And what's the domain and the range? In here, what's the domain? The domain are all the input value. So in here we have 3 input. There is nothing more than that. The range are all the output value. So the range of f are 2, 4, and 6. When I'm building f inverse, the input of f inverse are exactly the output of f. So they are going to be 2, 4, and 6. And the range of f inverse is actually the domain of f, which is 1, 2, and 4. So we're moving really backward. Okay, so let us a little bit define f inverse in general, mathematically in a way. So what is f inverse? Okay, so suppose f is a function. It means an assignment. So suppose f is a function. It means it's a rule. It takes an input and it is assigned to it a certain output. That's really what the function f is. Then f inverse of t, what's f inverse of t? Is the number x, f inverse of 2. Basically, it's the input of f that gives me 2 back. So f inverse of t is the number x such that f take x to t. Okay, so f inverse of something is the input. So the inside here, these are the output of f. So f inverse of t is the input of f that gives me t back. So that's really our definition. And so to say that f inverse of t is equal to x is really mean that f take x to t. Okay, so that's really the idea of f inverse. So it's the functions that move you backward. It's move you backward. So the picture that you can keep in mind for f inverse is the following. If f takes a to b, f inverse is the function will take b back to a. That's really f versus f inverse. So we're going to spend time today a little bit kind of, how to find the inverse of a function. First, if we have a table like this, finding the inverse is not actually hard. So you just move backward. So you take the output back to the input, output back, input, output back to the input. So the first example I'm going to do is a graphical example to help us really understand the concept. So I'm going to start with a graph. This is a graph of f. So this is my x. This is the input here. And this is f of x. Okay, so that's my function f. And I'm going to ask you several questions so that we can understand really the concept. So question number 1 is the following. Very simple question. I tried to make it so you guys can see everything clearly. So my first question is, what is f of 1? Okay, estimated. What do you think f of 1 is according to my little picture here? I want your input all the time. So what is f of 1? F of 1 means if this is 1, remember that's the graph of f. This is 1. What is f of 1? So from 1, you go back to the picture and you ask yourself, what is f of 1? Now, I didn't give you exactly the number, but it's intuitively a half. So f of 1 is equal to half. Now, what is f inverse of 1? What does it mean, f inverse of 1? Find f inverse of 1 means the value of x is the value of x such that f of x is equal to 1. In other words, what's f inverse of 1? It's the input, the input of f whose output is 1. So if I go back to the picture, what is f of 1? This one here become an output of f. And f inverse of 1 is what's the input that gives you 1? This is the f inverse. I move backward. 1 is an output value. And my question, what's the input that gives you an output of 1? That's f inverse of 1 right there. That's how you see it. So now, according to my picture, what is f inverse of 1? We don't want to confuse both of them. Okay, so what do you think f inverse of 1 is? That's an output value. I'm looking for the input where the output is 1. So I'm not reading anything. It's absolutely almost 2. F inverse of 1 is equal to 2. So that's what f inverse of 1 means. It means the input value where the output is 1. So this, what's inside the inverse, is the output of f. The answer is the input. We have that as an output. So we're moving absolutely backward. That's the picture. I'm moving backward. Okay, now I'm going to give you others. So we get this straight. So suppose I ask you what is f of minus 1. I'm going to write this one here. What is f of minus 1? Can we see it? Is that clear on the picture? Yeah. This is minus 1 here. F of minus 1. Okay. It's right there. Okay, so f of minus 1 is equal to minus 2. Okay. Now, what is f inverse of minus 1? Again, an estimate. Again, an estimate. Now, when you read f inverse of minus 1, this minus 1 here is what for us? This minus 1 here is an output value. So what is f inverse of minus 1? It means this is, no, why? Yeah, this is minus 1, right there. It means that's the input value. So the question is, that's an output value. What is the input that gives me f inverse of minus 1? That's really what I'm looking for. So this is minus 1. This is f inverse of minus 1. So according to my picture, is minus 1/2. Okay, I'm going to keep asking you questions so all of you can actually understand what is really looking for. So what's inside the f inverse are output values. I'm really after the input values. Very good. So let me ask you more questions. What is, let me see. What is f inverse of 2? Okay, I'm after f inverse of 2. Okay, everybody? F inverse of 2. It means, what is f inverse of 2? It means, let's write it in English, it means the value of x such that f of x is equal to 2. Now I go back, and of course, by now you guys see it. This is 2. F inverse of 2, I'm going backward. That's f inverse of 2. So f inverse of 2 is absolutely equal to 3. Okay, so that's the intuition behind the f inverse. Not exactly. That's the meaning, because the input of f inverse, the input of f inverse are the output values of the function, and I'm asking for the input value. So this here is an output value. It's right there when I have it by a graph. So that's an output value. So my question, what is the input who's give me this as an output? Since it's an output value, they are on the vertical axis or the y-axis. Okay. Right. Suppose I give you the following, like simple problem, which is like in Word. Suppose f is, so that's the graphic. That's how we do it. Graphically, how we find the inverse. Just look at the graph. Now, a very simple verbal problem. Suppose I don't have to write this. Suppose I have a function f that assign to every US citizen, so that's my assignment, I'm going to write in Word, the social security number. So we assume of course, every US citizen have a social security number. So let me write F here. So that's F. So F is a function, you give it the name of the citizen. Imagine you have, a computer program, you input the name of the US citizen, all of it. The computer program will actually spit out the social security number. What will become F inverse? F inverse will take what as input and spit what for us? So what kind of assignment F inverse does? What should I put here? What should I put here? Okay. Right. F inverse does the opposite. You give it the social security number, F inverse will give you the name of the US citizen who have this social security number. So if I say F inverse of, I don't know, 0, 2, 0, 3, 0, 4, 5, 6, 7, how many numbers? 6, 1, assume this makes sense, is equal to Joe Doe. It means the social security number of George Doe, it means that the US citizen who have this as social security is Joe Doe. That's really what this F inverse is about. Right. Now, there is some functions, there is no inverse for them. So it means that I cannot find F inverse for it. It doesn't exist. So let us talk a little bit about that. Okay. So here, remark, a note if you want. Okay, that some function that cannot have an inverse. So some functions don't have an inverse. What do I mean by that? Who can think of what I'm talking about? Do not have an inverse. Means F inverse doesn't exist as a function. So how can this occur? How can a function, I cannot talk about the inverse. I mean, how can a function, I cannot talk about if I reverse it, reverse the process. One is an undefined number. I'm trying to understand exactly when it is, if it is 0, what is 0? I mean, if I take this picture here, back to my picture, what is F inverse of 0? In this problem, what's F inverse of 0? It's 0 because this is the output. F inverse of 0 is absolutely equal to 0. Okay, so it's more subtle than that. How can a function fail to have an inverse? I can give you an example and then you tell me what's the problem. Suppose I take the following function. And I'm just going to give a table because it's easy for us to absorb. So the input are 1, 2, 3. And 4, let's have 3, 4. So these are the input values. And my output values are 2, 4, 4, 6. Okay? That's my function. And suppose I tell you, find F inverse. I mean, give me a table. That's what I did. That give me 5 F inverse, like what I did in the first example. Are we gonna encounter any difficulties? Back to you. Yes? Because where is the difficulty? Yeah, what is the difficulty? Exactly. So this function will not have an inverse because if I'm starting to build my function, okay, I sending 2 to 1. The minute I hit 4, I have multiple value. I don't know where to send it to. And so F inverse is not a function. So this function does not have an inverse because a function for every input, it has to have exactly 1. And here, f inverse of 4, so f has no inverse. Has no inverse because f inverse of 4 has two different output. So there is ambiguity. And a function, there should be no ambiguity in what it is assigned to something. So here there is ambiguity. If I tell you what's f inverse of 4, you're gonna ask me which one you want. The minute you ask me which one you want, it means there is something absolutely wrong. It means that's not a function. Okay, so that's a function that's not inverse. Now, who can think of a graph of a function where we don't have an inverse? So I gave you a table to make it actually kind of simple. Now, question number 2 is, who can tell me how the graph should look like so the function doesn't have an inverse? Explain it to me the best possible way. How I'm going to graph a function, and I want you to tell me how the graph should look like so this function doesn't have an inverse. So this should be a guideline. This should actually kind of guide us what's going on. I don't really, okay. I mean, I know you guys were taught this stuff in high school, but I want the graph. Very good. I like that. Okay. One of your classmates told me a constant function. That's a very nice example. This function has no inverse by any stretch of the imagination. Okay, so f of 0 is let us assume this is 4. 1 is sent to 4, 2 is sent to 4. But what's f inverse of 4? It's every real number under the sun. So this f has no inverse. And that's really a nice example. Okay. Okay, very good. Who can give me another one? That's a very nice one. I like that. Who can give me another one? Who can think of another one? Okay, try to tell me how to draw it. It's not very hard. I think you can, using chat, tell me how it is. Well, it is piecewise, not necessarily, because piecewise, I can build it like this, like that, like this. This will have an inverse. When it is a parabola, okay, this makes sense. Suppose it's like that. Okay, yeah. Why this also doesn't have an inverse? Suppose I pick a point right there. Let me pick 9. I tell you find f inverse of 9. It means I'm asking you for the input, whose output is 9. Okay, how many input has output 1? Absolutely 2 of them. That's an example where the function doesn't have an inverse, because f inverse of 9, I picked 9 just, why not? Is not defined, has 2 different input. Okay, so not every function has an inverse. It has to have a specific shape. The function to have an inverse, it means no output should be coming from 2 different inputs. So if one output is coming from 2 different input or 3 different input, the inverse does not exist. That's really what's happening. We have an issue with the definition of a function. Okay, now we're gonna spend time talking about, okay, if I have a graph, I ask you about f inverse of stuff, you can do it. You can look at the graph. If I give you a simple table, we manage to do it. So the question finally, yes, whenever there is ambiguity, it doesn't have. Whenever you cannot tell me clearly what's the f inverse, it means there is no inverse. Because whenever for one value you have 2 different input, the question is, okay, which one you want? And that's where the problem comes. Okay, now we're going to talk about that, of course, the inverse, but what if I have a formula? So the function is given by a formula. How are we going to find the inverse? Okay, so we're going to spend time working on that now. But unless the crucial idea is really to understand the formula, that's really what matters the most. Once we understand this, we actually can start understanding how to construct the inverse. So now I'm going to do the following. We're going to take a bunch of functions. So how to find the inverse using, so how to find the inverse if a function is given by a formula. Is given by a formula. So I hope to do at least 2, and I will start with an easy one. Okay, suppose my function f of x is equal to the following. So suppose f of x equals, so example number 1, f of x equals, so it's a formula, 3x plus 4. Okay, so I'm starting with a very simple one. So this function will have an inverse. Graphically, if I graph this function, we know that this is a straight line, and the intercept is at 4, and the slope is 3. So if I graph it, I get, this is the picture. Okay, so this function have, graphically, there is an inverse. For every output, there is only one input. Okay, that I can, that whose output is what I started with. So now I'm gonna start the following question. Find f inverse of 2. Okay, is that an easy or a hard question? First, what does this mean? Find f inverse of 2. What does it mean? It means, so this is 2. This is 2. And this is 4 because that's the intercept at x equal to 0. This is 2. Find f inverse of 2. It means basically I need to find the x. That's what I want, such that. Okay, it will be, of course, after, but now we have to find it. So find f inverse, it means, so what does it mean? It means find the value of x, such that f of x is equal to 2. That's what it means. So it's going to be a negative, but we have to actually go after it. So what's f inverse of 2? So it means I want to find which x give me the output of 2. So how we do that? We've done this, of course, a lot. Means we're going to set 3x plus 4 equal to 2 and solve for x. Okay, so finding this, it means we have to set the function equal to 2 and solve for x. Okay, let's do that. So let us solve. Okay, how we solve? We need to isolate the x. So it's gonna give me 3x equal 2 minus 4. So it's a minus 2. And now I need to isolate my x. I divide by 3 across. I get x equal minus 2 over 3. It means for me, f inverse of 2 is minus 2 over 3. Okay, so that's the point here. This point right there, this is actually minus 2/3. Okay, so when I have a formula, I can find the exact value by proceeding like this. All right, let me ask another question, and this one along the same line, no more, no less. Suppose I ask you to find let's say f inverse of 3. Okay, are we going to do the same thing? So 3, actually, let's see 5. It doesn't matter. Let's pick 5. F inverse of 5. It means again, this is 5. I'm going to find the input where the output is 5. So it means we need to find x, find the value of x, such that f of x is equal to 5. All right, that's the same thing. Okay, I'm going to repeat verbatim the same approach. We're going to get 3x plus 4 equal to 5 and solve for x. So what do we get? Subtract 4, both sides will get me 1. It means x is 1/3. So f inverse of 5 will be 1/3. Are you with me? Okay, let me ask you a simple question. If I want to ask you to find f inverse of 10, are we going to do the exact same thing? What do? We're going to pay 3x plus 4 equal 10 and solve for x. So the question is, can I find a formula for f inverse? It means, can I find a rule that if I give you the output t, you can give me the input? So instead of doing it for every single value, can I find a formula? So my question is the following now. Find a formula for f of inverse of t. It means find the rule that if you give it the output, it will spit out the input. So find the formula for f inverse of t. So t here represents an output value. And the problem is, find a formula for that. Instead of doing it several times, give me a formula for it. So let us rephrase this question. What does it mean, find a formula for f inverse? It means that find x such that f of x equal to t. So in this case, I'm going to find a formula for x in terms of t. And how we will do that? And that's how we're going to do it actually a lot. To do this, we set verbatim. We set the function equal to t. So instead of 5 and 4, okay, we set f of x equal to t, and we solve for x. That's what I did here in terms of t. Every word is important now. So find a formula for f inverse of t. It means I need to find the input where the output is t. How do we do that? We set f of x equal to t and solve for x in terms of t. So t will be what I know. T would represent the 5, it represents the 2. But I'm not going to repeat myself a million times. I said, okay, let me call this t, and then I need to solve for x in terms of t. Okay, so let us do this problem, and then we'll do another one, and you guys will help me in the other one. So I will do that. So let us find a formula for f inverse. So how do we do it? So we're going to set f of x, and my f of x this time is 3x plus 4. We set this equal to t, and we're going to solve for the input, because that's really what I want, in terms of t. So I'm looking for a general formula this time, instead of doing it a million times. So your unknown is x. For you, that's the unknown. And t is what you know, and that's the unknown for you. So we're going to solve for x, that's my unknown, in terms of t. And don't be scared that we have a t. How would we solve? We're going to isolate my x. That's how we solve. To isolate the x, we're going to take away 4 from both sides. So we're going to take away 4. So I'm going to solve now. So I will get 3x equal t minus 4. Now I need to isolate x. Then I'm going to divide by 3 across the board. Look at me, x equal t minus 4, the whole thing divided by 3. So this tells me that. So it means that f inverse of t, it means if t is any output value, what's the input? The input is going to be t minus 4 over 3. And that's really the formula for the input in terms of the output. So if you give me the output, that's the formula for the input. Now, watch carefully when I did those. When I compute f inverse of 5, so let us note. When I compute f inverse of 5, what plays the role of t is 5. So if I put 5 in here, means my output is 5. This formula is giving me 5 minus 3 over 3. It means it's giving me a third, which is exactly what I got when I computed f inverse of 5. Okay, so the problem here, instead of doing it for every output by itself, find a general formula for an arbitrary output that I call t, and find a general formula for it. Okay, now we're going to start practicing those together. So I'm going to give you a function, and I'm going to ask you like this one. Question number 1, find the inverse with a particular value, and then find a formula. So here we are. Suppose I take f of x equal 4 times the square root of x. Okay, so that's my function. Now, some of you may know the graph, some don't, but the graph of this function is like that. So basically, this function has an inverse. Every output, there is only one input associated to it. So question number 1 is find f inverse of 2, for example. Okay, that's my first question. So I'm going to give you a minute to find it, and then we're going to find a formula. So find f inverse of 2. First, set it up correctly. What are you looking for? The 2 is here. I'm looking for the input. That's what I'm looking for. That the output is 2. So this 2 here is an output value. I'm looking for the input. Okay, you guys have a minute to do that. And then I write it. Okay, whatever answer you have, just put them on chat so I can start seeing what you guys are doing. Okay. I can't follow. I want a value. I want a value. It means I want this one. Okay, I want more answers because I have to see what you guys are doing. So I picked only one number. Then we find the formula, but I want to make sure you can do one number first. Anybody else? Okay. More? Okay, let's do it together. Let's do it together. So find f inverse of 2. First, what does it mean? It means we need to find the value of x, is the input value, such that f of x equal to 2. So first, put it in front of you what you want to do. So it means how we do that. We set f of x equal to 2, and we solve for x. Okay, that's what we're going to do. All right, how are we going to solve for x? I mean, we're not going to let the square root of x scares us, all right? The idea is first we're going to isolate the square root by itself. So how do we isolate the square root? So we're going to divide by 2 both sides to isolate it, okay? So this is going to give me 2 over 4. It means the square root of x is a half. Okay, so as I'm working, for those who had a mistake, just see where did you get it. All right, are you with me so far? Are you with me so far? I want a yes or a no. Okay, great. Now, I want x. How can I get x from the square root of x? Where did it go? We divided by 4. I didn't go anywhere. We divided by 4. 2 over 4 is 1/2. Okay? Now, we're going to take the square because I want x. And I know if I take the square root and square it, because I get x, because that's the definition of the square root. The square root is, by definition, is the number. When you square it, you get x back. So square root of 4 is, what's the number? When you square it, you get 4 back. That's becoming 2. That's the reason to cancel out. So it means it's 1/2 square. It means x equal 1/2 square. It means 1/2 times 1/2. X is 1 over 4. So it means F inverse, that's what we're looking for. F inverse of 2 is 1 over 4. Okay. So, right. So this is 2. That's the F inverse. So the F inverse is 1 over 4. That's really what I am asking for. All right. So we did it for one value. So now I want the formula, because this will help us a little bit to figure out the formula now. Okay, so now question number 2 is find a formula for F inverse. Okay, so now is find a formula for F inverse. So question number 2, question number 2, find a formula for F inverse of t. So what do they mean here? The idea is that instead of doing it for every value, so instead of asking you F inverse of 2, F inverse of 3, and so on and so forth, I want the formulas. It means I want a rule so that if I know what the output is, I'm going to call it T. I want the formula to tell me, okay, what is your input in terms of this output? Okay, so that's really what the question is. So how are we going to do that? So find F inverse, it means, again, verbatim, it means you're going to find x. You're going to find x such that f of x equal to t. So now t is really I know it's the x which is my unknown. I'm after my x. Okay, so how do we do that? So we're going to set f of x equal t and solve for x. X is my unknown in terms of t. Okay, so instead of putting 2 here, I'm going to put t. And I'm going to solve everything in terms of t. Now we're going to do verbatim what we did before. Verbatim. So what do we did before? We need to isolate the square root. Okay, how do we isolate the square root? We need to divide by 4 both sides. So I'm going to divide by 4. 4 is not disappearing by any stretch of the imagination. I divide by 4. So basically, I'm doing this. And now the 4 and 4 simplify, which will give me the square root of x, t over 4. So what is x? Now I square both sides. Over 4 squared. It means x is t over 4 times t over 4 is t squared. Remember, if you have a over b, the power, it's an over bn. So that's t squared over 4 squared. Or if you want, x is t squared over 60. So now the rule is, what does F inverse do? Whatever you give it, it will spits out t squared over 60. So again, the idea is that of doing it for every value, you can do it in general. So let us see if it fits our problem. Here, I took t to be 2, and I got 1, 4. So if I put t to be 2 in here, will I get 1, 4? So f inverse of 2 should be 2 square, which is a 4 divided by 16. 4 divided by 16 is absolutely 1 over 4. Okay, so that's how we're going to do that. All right. The last problem is along the same line, fairly simple, but we're going to jump to the formula immediately. So suppose I give you the following. Let f of x equal cubic root of x plus 1. Okay, it's a little bit harder, but we can do it. And this problem, because we don't have a lot of time, the question is find a formula for f inverse of t. Okay, find a formula. We're gonna do this. It means we need to find the input x where the output is equal to t. That's what we have to find. So what we're going to do, we're going to set f of x equal to t and solve. I repeat that in this scenario, x is the unknown, and solve for x in terms of t. Okay, all right. So you guys have to help me out. How would you do that? So x is my unknown. X is the one I'm going to be after, and I want to solve for it in terms of t. So tell me what to do if you were doing a problem like that. What would you like to do? All right. Everybody tell me, okay, subtract 1. Of course, because I want to isolate this. So I subtract 1. Okay. All right. And then we have to divide by 4. The whole thing by 4. Very good. And then what am I supposed? Remember, you have to isolate your x. I didn't isolate it. So now I have a cubic root of x. Okay, I have to take, how can I get rid of the cubic root? I say, you know, what's the cubic root? It's the number. When you take it to the power 3, will give you x back. That's really what the cubic root is. So we're going to take equal to this, the whole thing to the power 3. Okay, that means x is t minus 1 over 4 to the power 3. So f inverse, the rule for f inverse, so if you want any output, the input that gives you an output of t could be obtained by the formula t minus 1 over 4 to the power 3, or you can write this as t minus 1 to the power 3 over 4 to the power 3, because here you're multiplying t minus 1 over 4 by itself 3 times. Let's give you this divided by that. Okay, so that's how we find the formula. But we shouldn't forget what we're doing. It means this is an output value. And I'm trying to say, okay, can I find a formula that gives me the input in terms of the output? We always gave you the output in terms of input. F inverse is the one that reverses the process and gives you the input in terms of the output. Okay. All right, I definitely stop at this time. You will have a MyLab no, not MyLab, you guys, you have the Moodle homework and the regular homework. And this time, I think the online will be due next Wednesday, as usual. Okay, everything will be clear on Brightspace this evening. All right, you guys can start the quiz. I have to leave at 2:15. The quiz is due at 2:30, but I have to end the meeting at 2:15 myself. But it's due at 2:30. But I will end it at 2:15. You guys stay an extra 15 minutes if you need to. All right? Okay, please get going. Go to your quiz.